Type 1 diabetes is caused by autoimmune destruction of the pancreas that results in an absolute deficiency of insulin. It makes sense that the treatment of type 1 diabetes is to give insulin. Now, this is true, but unfortunately, it's not quite that simple. So let's talk about treating type 1 diabetes. And before we get into the specifics of the treatment, let's first briefly review some of the metabolic states in the human body. And there are two general states. You have the absorptive state, in which the body takes energy and stores it, and you have the post-absorptive state, in which the body takes this stored energy from the absorptive state and utilizes it. Now, this absorptive state here is driven by the hormone insulin, whereas the post-absorptive state is driven by the hormone glucagon. Now, throughout the day, the human body will typically fluctuate back and forth between this absorptive state and this post-absorptive state. So to get a better understanding of how this looks, let's draw what I'll call a physiologic timeline. And let's just bring in a graph here to help describe this timeline. Now down here on the x-axis, we'll have the time of the day. And right here in the middle, we'll have noon, 6 in the morning, 6 at night, and midnight, and then maybe we'll put 3 a.m., 9 a.m., 3 p.m., and 9 p.m. Now, as I mentioned before, the body will fluctuate back and forth between this absorptive state and post-absorptive state. So let's see that here. And if you look closely, this fluctuation back and forth makes sense. Here, around 6 a.m. when you go from this post-absorptive state while you're sleeping, and then you eat breakfast, and then you'll go into an absorptive state because you need to absorb the nutrients from the food in breakfast, and then as your morning goes on, you go back into this post-absorptive state, and so on and so forth. Now, these changes back and forth between these metabolic states are driven by these hormones, insulin and glucagon. So on the y-axis here, let's put in these hormone levels. So in purple here, we'll put in insulin. And then in green, we'll do glucagon. And what you can see from this is that it's really insulin here that's driving these changes between the post-absorptive state and the absorptive state. And glucagon also plays a role, but its level doesn't vary nearly as much as insulin's level throughout the day. Now, since in type 1 diabetes, the body doesn't produce enough of this insulin, it makes sense that the goal of treatment when we're treating type 1 diabetes is to give insulin that will try and mimic the body's normal production of insulin. However, when we're treating type 1 diabetes, just giving insulin maybe once or twice a day, as is done with most medications, doesn't really work because the levels are changing so frequently. So then how exactly do we manage type 1 diabetes? To get a better understanding of this, let's erase some of our work. Now, fortunately, physicians and pharmacologists have created a very elegant method for treating type 1 diabetes, and this method is known as the basal bolus strategy. And in order to understand this concept a little bit better, let's first talk briefly about insulin. Now, insulin is a peptide hormone. And as such, that means when we give it as a medication, it can't be taken in a pill form because the stomach and digestive system would break down the peptides or the protein of insulin into its component parts before it could be absorbed. And therefore, insulin must be given as an injection. And there are many different types of insulin that are available for use in the treatment of diabetes, and they are classified based on how quickly they take effect, which is known as the onset of action, and how long they work for, which is known as the duration of action. So to get a better understanding of this, let's create another graph similar to this one that we'll call the pharmacologic timeline. And on the x-axis here, we'll put that duration of action. And this will be in hours, so we'll have maybe 3, 6, 9, 12, 15, 18 hours here. So one of the three main groups of insulins that can be given when treating type 1 diabetes are known as the rapid-acting insulins, and their pharmacologic timeline looks something like this. And these rapid-acting insulins usually take somewhere about 15 minutes to 30 minutes before they start working, and their duration of action will last, you can see here, somewhere around 4 to 6 hours. Now, the next major group of insulins are known as intermediate-acting insulins. And these intermediate-acting insulins, you can see by the graph, take a little bit longer before they have an onset of action, about 30 minutes to an hour, and then they last a little bit longer than the rapid-acting insulins for somewhere between maybe 8 to 12 hours, as you can see on the graph here. Now, the last major category of insulin are known as the long-acting insulins. And as you can see on this graph, the long-acting insulins all take even longer to take action, somewhere in the order of maybe 1 to 4 hours, and their peak action is not quite as intense as this rapid or intermediate acting insulins, and their duration of action is much longer. Depending on the type of long-acting insulin, it can be somewhere between 12 and 24 hours. So now that we have a little bit better understanding of the different types of insulin and why it needs to be injected instead of being taken as a pill, let's go back to this physiologic timeline here. And let's specifically look at this insulin level. Now you notice that the insulin level never goes all the way down to 0. There's always this baseline level here, and we'll call this the basal level. And then intermediately there are these peaks, which we'll call boluses. And these boluses occur after we eat, and they're what drive the transition from that post-absorptive state to the absorptive state about 3 times a day, depending on how often you eat. Now, hopefully what you can see by this is that if we transpose a couple of these graphs from the pharmacologic timeline onto the physiologic timeline, we can use injectable insulin to mimic this physiologic timeline in order to treat type 1 diabetes. So for these boluses, these kind of rapid peaks, you'll notice that they look somewhat like the rapid-acting insulin here. So let's put that on there. And then this basal level here, this constant level, you can create with a long-acting insulin. So we'll put that on the graph. Now, hopefully what you can see by this, and it's starting to get a little crowded here, so I'll highlight it, is that by using this basal bolus strategy, someone with type 1 diabetes can kind of mimic the natural levels of insulin that the pancreas should be producing. And this is why this basal bolus strategy of treating type 1 diabetes is very efficient, because it mimics what the body would do if the pancreas was working properly. So an overview of the basal bolus strategy is that usually once or twice a day, depending on the type of long-acting insulin, say in the morning and then again at night, someone with type 1 diabetes will take a dose of insulin, of this long-acting insulin that will serve as this basal rate, and then at mealtime they'll take an additional dose of the rapid-acting insulin to cover these boluses to help the body transition from the post-absorptive state here to the absorptive state, to absorb the energy in the meal they just ate. Now, it's important to note that this graph demonstrates the principle of the basal bolus strategy, but it is somewhat of an oversimplification, and that proper insulin management requires one to be very diligent with their insulin dosing and administration. This is especially important in regards to the bolus doses here. And this is because the amount of insulin that someone is going to need to take with each bolus dose will vary depending on what their blood sugar is at that time, as well as on how many carbohydrates they're planning on eating. So in order to properly manage their insulin regimen, individuals with type 1 diabetes must regularly check their blood sugar levels and adjust their insulin dosing accordingly. Now, type 1 diabetes can be a very serious and potentially even lethal disease. However, with diligent adherence to the basal bolus strategy and regular appointments with one's physician in order to adjust the insulin dosing, as well as monitor for complications, someone diagnosed with type 1 diabetes can still live a very healthy and long life.